Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
The shortest month of the year has ended, though for those locked down, it may not have seemed that short at all. So, as a diversion, here is podcast number 76 for the month of March 2021, and I'll waste no time in getting to the puzzle of the month. Chris Smith, he's Scottish Teacher of the Year 2018, and he's the author of a very popular maths newsletter, and he wrote a puzzle about his 3 children. He says, I gave Heidi, Logan and Daisy a whole number I was thinking of. Heidi said, I'm multiplying your number by 4 or 5. Logan said, I'll add 4 or 5 to Heidi's answer. And Daisy said, I'll subtract 4 or 5 from Logan's answer. Daisy told Chris the final answer to their unpredictable calculations was 173. So what number did Chris give to his children? Well, the answer and my method for finding it is going to be at the end of this podcast. But in the meantime, you'll have plenty of time to think about that as I talk about the developments on the Transum website this last month. Now, as I'm recording this, I'm also doing a bit of multitasking. My Pythagoras theorem video should be finished in time for the 1st of March, but as yet I don't know for sure, as I just seem to have lost one whole section of audio that I recorded. Isn't that annoying? Anyway, while I figure that out, it should be there in time. But there is another video that was uploaded last month, the rounding video, and that was produced earlier in February and has already had quite a few hits. It's in the help tab of the rounding exercise, and I hope it has helped students already rounding numbers to decimal places, significant figures, nearest power of 10 and so on. By the way, you can find all the links that I'm talking about to these exercises in the newsletter, which is at transum.org/newsletter. Right, what else has happened? Well, a new level 6 has been added to the ratios exercise on the suggestion of a Transum subscriber. It provides questions of a type that are often misunderstood by pupils according to Mr. Barton's diagnostic questions, which are really useful, well, particularly the feedback. So have a look at level 6 of the ratios exercise. Hopefully that set of exercises covers everything that students need to know in secondary school. So hopefully you'll find that useful. Now, are exercises better than games, or is there a place for both in maths learning? Well, I firmly believe it's the latter. And a good example of a game would be the new Dicebra game that was created last week. So this new game includes substitution, inequalities, and provides lots of excitement because I have tried it with a student remotely using Zoom's screen sharing and the feature that allows one person to interact with the screen shared by the other person, which is a relatively new feature to me, but it makes things far more interactive. And of course, lots of other Transum games can be used in this way too, as I mentioned in last month's podcast. And I think this is going to be particularly well used during one-to-one tutorials for the last 5 minutes of the lesson to sort of finish on a very exciting note. Anyway, have a look at that. The link's in the newsletter.
You can find Transum Mathematics at www.transum.org.
Over the years, I have received lots of inspiration for new Transum activities from Twitter, and last week I saw a fascinating tweet containing a question from Kit Yates, which at first glance seemed quite easy. There was a picture of what looked like a semicircle and the question was, true or false, this shape has 2 right angles. Now, of course, I initially thought that there can't be any right angles in a semicircle, but then on reflection and thinking of the notion of approaching a limit, I had to think twice. We are quite happy thinking of the gradient of a curved line at a point, so why doesn't the same thing apply when the curve of the circumference meets the diameter? That is assuming the straight line in the diagram is a diameter, because there's nothing to say that it is a perfect semicircle. It looks like a semicircle, but of course that's another thing to consider. It could just be another chord passing close to the center of the circle, but not quite going through it, that borders the diagram. So, I suppose the key ingredient here is the definition of a right angle. So where do you go for your definitions? Is the angle between curves defined as the angle between their tangents at the point of intersection? Should the accepted answer depend on the pupil's age or stage of mathematical understanding? So I decided that this question can initiate lots of discussion. I've put a link in the newsletter to the Twitter discussion that went on. And I've developed it into an advanced starter called Curved Angles. So hopefully that will prove interesting for maybe year 12, 13 students to give their opinions. Also on Twitter, I saw a beautiful collection of 26 bar charts showing the frequencies of letters of the alphabet grouped by their positions in English words. That information adds another dimension to the analysis of coded messages in the Code Breaking Challenge. So if you go and have a look at that and cycle through the tips, you'll see how many items there are that you could consider or use to help you deciphering messages. Anyway, these bar charts, I've copied them there at the bottom of the Code Breaking page. Have a go yourself. And think, if you see double letters, what are all the possibilities for double letters in English words? It's not limitless. There's only a certain number of letters that can appear as double letters. Do you know what letter is most likely to be the one after an apostrophe? And how many single letter words do you know? Well, the answers to these questions will help you with this code breaking challenge. Bit of fun, and every time you load the page, by the way, you get a new message to crack. So, I hope you have found that the Transom website is now running much better than it was previously, because over half term, a great deal of my time was taken up managing the migration to a new, very expensive virtual private server hosted by a very large web hosting company. At times, the process was very frustrating, particularly when I phoned to speak to a technician at this large hosting company, and it was never the same person that I'd spoken to before. I'm sure you can imagine what it's like. Anyway, there were so many little things that had to be configured, and I was so relieved when I saw that it actually worked. So, hope you enjoy that. Right, well, thanks to Chris Smith for giving me permission to use his puzzle in this podcast, and here's how I solved it. Of course, I began, as you would predict, by let the number that Chris first thought of be n. So Heidi multiplied that number n by either 4 or 5, so she got either 4n or 5n. I next combined Logan's and Daisy's operations to find their overall effect, and I saw there were 4 possibilities. So if Logan added 4 and Daisy subtracted 5, that was a net effect of subtracting 1 from Heidi's total. But Logan could have added 4 and Daisy subtracted 4, which would have had no effect, or Logan could have added 5 and Daisy subtracted 5, which would have had no effect. So the only other possibility is that Logan added 5 and Daisy subtracted 4. The net effect is to add 1 to Heidi's number. So I know that Daisy's answer must be one of the following: 4n minus 1, or 4n, or 4n plus 1, or 5n minus 1, 5n, or 5n plus 1. And as her answer was known to be 173, we can discount all but one of the possibilities. Because the nearest multiple of 4 to 173 is 172, and the nearest multiple of 5 to 173 is 175, so can you see that the only possibility is 4n plus 1? That's one more than the multiple of 4. So if 4n plus 1 is equal to 173, you can solve that as a little simple equation and get n is 43. So Chris was thinking of the number 43. Hope you enjoyed that. I did. That's all for now. Bye.
Thank you for downloading and listening to the Transum podcast. You can find the website at www.transum.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transum subscriber.